Welcome to part 2 of our video series exploring the different exponent rules and the shortcuts that we can use in order to solve problems involving exponents faster. In this video, we're going to be looking at some of the more obscure rules, that being what happens if you have an exponent that is 0 and what happens if you have a negative sign in the exponent that we see here. Now, the first question to answer is, in what situation would you actually get an exponent with a negative sign? Well, we can actually do an example of that uses the same rule as dividing exponents. So if we have 6 to the exponent 3 divided by 6 to the exponent 5, if we follow the division rule where we simply take the exponent in the numerator and subtract the exponent in the denominator, you would end up with the rather odd exponent of -2, meaning that 6 to the exponent 3 divided by 6 to the exponent 5 must be equal to 6 to the exponent of -2. Well, we still don't know what exactly this means. But if we expand out each of our exponents, this will actually become self-evident. So 6 multiplied by itself 3 times is what the numerator is equal to, and our denominator, we have 6 multiplied by itself 5 times, like so. Now, we remember from basic division that anytime you have a number multiplied by itself, this is equal to 1. And since multiplying any number by 1 doesn't change what the other number is, we can effectively ignore a number anytime we divide it by itself. So 6 divided by 6, we can cancel out like this because multiplying anything by 1 doesn't change what the other number is. So if we go ahead and cancel every time we have 6 divided by itself, that means that we would have nothing left on the top of our numerator, or on the top of our fraction, the numerator rather, and so we can simply write 1 here because our entire exponent, 6 to the exponent 3, got canceled by the denominator like this. And in the denominator, we can see that we have 6 multiplied by itself, a total of 2 times here. So this must mean, because all of these are equal, this must mean that 6 to the exponent of -2 must be equal to 1 over 6 to the exponent 2. Well, what exactly can we do to the base 6 in order to get 1 over 6? Well, if we remember what a reciprocal is, a reciprocal is simply what we do to a fraction when we take the numerator and the denominator and flip them. And we know that any integer or natural number can also be written as a fraction over 1, like this. So if we take the numerator and the denominator and flip them, and then we have the positive exponent in the denominator like this, this actually explains perfectly how 6 to the -2 can be equal to 1 over 6 over 2. So if we try that with our example here, we see that there is a negative exponent here, and the negative exponent therefore tells us to take the reciprocal of our base. So 2 is a natural number, which means it has an invisible denominator of 1. So if we flip 2 over 1, that means that we would have 1 over 2, and then we simply rewrite our exponent as positive in the denominator like this. So 2 to the -3 exponent becomes 1 over 2 to the -3. And if we were to write this in expanded form, this would be 1 over 2 times 2 times 2. And we can see how this negative exponent works based on the example that we've done here, and how we would end up with a negative exponent if we have specific types of exponent division like this. Now that we know what negative exponents mean, and now that we know that anytime we see a negative exponent, we're simply taking the reciprocal of that exponent, that actually makes this rather complicated fractional negative exponent to actually be very straightforward, because all we do is take the fraction as our base and flip it. So in this case, we would have 3 over 2, and then we simply rewrite the negative exponent as positive because the negative simply means take the reciprocal of it. So if we were to expand this outward, we're doing 3 over 2 multiplied by itself twice, which we can then write as 3 times 3 in the numerator divided by 2 times 2 in the denominator, and that's why the simplified form of our fraction would simply be 3 squared over 2 squared like this. So again, the negative exponent of a fraction, take the fraction and flip the numerator and the denominator whenever we see a negative sign, and then apply the exponent to both the numerator and the denominator respectively. And that gives us a pretty predictable process behind how to do negative exponents of fractions, simply by flipping the numerator and the denominator and then applying the exponent to both of them like so. This brings us to the final rule in our video, that being what happens if we deal with an exponent of 0. Well, what exactly is an exponent of 0? Well, 2 to the exponent 2 is 2 multiplied by itself twice. 2 to the exponent 1 is 2 multiplied by itself once, which would simply be 2, and therefore 2 to the exponent 0, let's just rewrite this more neatly, 2 to the exponent 0 is multiplying it by itself 0 times, which means that we would actually have nothing here, except we can remember that anytime we have an exponent, we actually have the base multiplied by itself, and then we have an invisible times 1 at the end here. Well, if we have no number multiplied by itself, meaning a number multiplied by itself 0 times, all that you have is the times 1 here, and this is why anytime we have a 0 exponent, because we are multiplying the number by itself no times, all that we have is the times 1 at the end here, and that's why 0 exponents are always written as 1. Now, to conclude this video, we can actually take all of these rules and apply them to the following situations that have variables. So all of these rules don't just apply when we are taking the exponent of a constant, but they also apply to variables as well. For example, if we take the multiplication rule, we can simplify our first example by simply adding the exponents. A to the 7 times a to the 4 means that we are multiplying a by itself a total of 11 times, because 7 plus 4 is equal to 11. Likewise, with the division rule, we can simply say that we are multiplying w by itself a total of 5 times, because w to the exponent 8, w to the exponent 3 in the denominator, 8 minus 3 is 5. Likewise, if we have an exponent of an exponent, we are taking h to the 4 and multiplying it by itself 6 times. So all that we would need to do is multiply the exponents. 4 times 6 is 24, would be the overall exponent. And then here we have a negative exponent of a fraction. The negative simply means that we are taking the reciprocal, meaning that we are going to flip x and y, and then we apply the exponent without the negative sign like this, which means that the exponent 4 applies both to the numerator, x, and to the denominator, which is y. So we can see that all of the exponent rules that we have learned over the 2 videos previously also apply to variables. This concludes our video on exponent rules. In order to test your knowledge of exponent rules, you can take a look at the practice problems below and see if you can first identify which exponent rules to use, and then evaluate by simplifying, by combining each of the exponent terms into a single exponent before actually using your calculator to solve for the total exponent that you figure out.